Okay. All right. So we're going to now to talk about the graphic OLED display. So what we are doing is, once the SRAM lab is done, you will notice that the aim is to multiplex the pins to also manipulate the OLED display. Now, we chose this particular display. It's a little bit different from what you have been working with before, which is just an LCD screen, right? And the difference is really that you can do pixel by pixel manipulation of the screen. It's kind of fun. So what is the display mode? It's what we call a passive matrix, and effectively these pixels over here will be lit up yes or no one by one, and it goes through here all the time. But it goes so fast that your eye will see a whole picture, even though most of the time all the pixels are just not on. Actually, it's pretty cool. So the pixel in each line are actually off most of the time, so it's pretty interesting. Now the pixel resolution that we have for this OLED display is 256 by 64, but what we're going to use is this particular driver. So it has an OLED driver on this OLED display that you have been buying, and the driver actually talks about 480 segments and 128 comments. We'll talk about what that means, but the point is that with that you can manipulate, in fact, 480 times 128 pixels. It's actually, this is wrong. This should be 120 times 128 times 4 bits, and 4 times 120 makes 480. Alright, anyway, 480 times 128 bits. So that's the maximum pixel display, and this particular driver is used in a lot of their products, I suppose, because the OLED here that you bought is just a subset, has a resolution, it's just a subset of the 480 times 128 pixels. So that's kind of interesting. So we're going to work with this. According to the data sheet, you need a power supply of about 3 volts, and that will also be something that we'll be talking about, because there's a little bit of a problem that we figured out ourselves too late, but then luckily everything kept on working, so now we know that it doesn't matter too much whether this is well, we will talk about it later. Anyway, so what do we see here? We see 120 columns, and over here 120 columns, and here 128 rows. And the OLED visible area is just this part, so it has a certain range. That's it. And each cell over here will represent 4 pixels, and that's why 4 times 120 makes 480 pixels on a single line, and so times 128 is the complete resolution of the whole area. And the OLED is just a small subset. Alright, so what are the pins over here? We have, of course, the power pins and so forth. We are going to direct the OLED to tell it whether we're going to give it a command or data, especially if you do initialization sequence, because as always you need to initialize your component, in this case the OLED display. You will need to give it a lot of separate commands. So you will definitely need to implement how to write commands. And maybe the difficult part of this particular lab is that if you look at a data sheet, you need like a ridiculous number of commands for the initialization sequence. I don't know, 10 more, I don't know exactly anymore, but quite a number. And each of them are very well explained in the data sheet, but you need to still implement those. So we have a write signal, we have a read signal. We are not going to do reading from the display, we're just writing to the display. So we'll actually, in effect, not use this pin, but we will set it to, in this case, a high value, because that's what the datasheet requires us to do, and that's what we will do. So we'll have 8 bits that we're going to transmit, and those 8 bits are 2 segments, as you will see later on, that you will be able to program. So each pixel is 1 bit. There are 4 pixels per segment on the previous slide over here, per cell, I should say, sorry. And you will actually be writing 8 bits at a time, meaning 2 neighboring columns all the time. So a reset signal, you need to enable the OLED, and then we have 2 more pins that can be used to indicate what kind of mode of operation you prefer. So we're going to choose this particular one, and that means that you need to set this pin to high and this one to low. So that's what you'll be doing. And yeah, so in this mode we will have separate read and write enable, but what we're going to do is we're going to set hardwire the RE pin to high, because you're only going to do writing. So other modes are these other types of interfaces, and as a matter of fact, for testing you will use SPI again, and that means that you will set up this particular mode. So you will change this, it will not be 1.0 but something else, to communicate through SPI, and that is how you can then test your OLED display once it's all working, meaning that you have tested all your coded up commands and stuff like that, and the initialization sequence in particular works fine. Then you're ready to get into this mode, and then after that you can parallelize it, sort of multiplex it with the SRAM itself that you have. So the interface here does resemble the writing to SRAM, and that's why we are also happy to multiplex with it. And in our way of working with it, you never, do not need to write to both the OLED display and the SRAM at the same time, right? You always do things in sequence. So you just make sure that if you want to manipulate, the OLED, you just manipulate the OLED, and you're not mixing that up with also SRAM reads and so forth, and the writes and so forth. But that makes sense, right? You have your library that already creates these atomic operations for you, so you're never going to mix that up with other commands. Anyway, so what do we have here? So if you just highlight the part with the OLED, you see a very similar layout as what we had for the SRAM. So now we use the same pins over here, and here another 2. Those 8 go in the data pins over here. We have control lines. We have one more. We have either we want to explain whether the OLED should interpret the incoming data as a command or as data, and then you have the write and the read enable and so forth. So that's what we'll be doing. All right. So and then you have the BS0 and the BS1 pins set to high and low respectively, right? So that this sets this particular mode, that you will change, of course, accordingly if you want to do this particular type of communication with the OLED. So that's what we will have. And generally, if you're looking at this type of how we write, well, effectively, what you do is you you can choose whether to write a command or write data. The only difference is that the DC line is 0 or 1. So here you have it either at 1 or 0, depending on how to interpret the data that you put down here. So the read is high. That's why that pin is just set to high. And if you want to write, then you need to first, put this to low. Now you are going to make sure that this one is low as well, because on the rising edge you will actually, then the data has to already be there. Then the data will be read by the OLED display and will be interpreted as such. So you write to the OLED display when you go on the rising edge over here, which is indicated over here and over here. So that's how this works. So this is a very global overview, just to explain to you that this is the initialization sequence. That's quite a bunch of stuff, right? So you notice that you need to do all kinds of functionalities that you need to interpret. So actually it's more than 10, right? So you need to do command log, display on off, column address, row address, display clock. So that's what you need to do. But it is very simple. Each of those functionalities that you come to program in your library will be just a tiny bit of code, because you just need to tell the OLED display what command you are interested in. Okay, so set phase length, or take another one, or which one are we going to do actually? Let me see whether I can see that in here. Oh, maybe not. I cannot see that easily. But each of these has a certain hexadecimal number. So you first send a command to the OLED. That is then being interpreted. Oh, we're now in this functionality, for example, set contrast of the screen or whatever that means. Then the datasheet will let you know that you need to give it some input. For this is the input apparently. That you give it through the initialization sequence, but that input is being interpreted. It's like data that you start to write to the OLED display. It may expect one piece of data or two pieces of data, but the datasheet will show you. So that's what we're going to do, and we'll go through a couple of slide decks here, and you will see what's happening. So, but let's talk about assignments. So, what are the different tasks? Well, they're all incrementally again, right? So what you want to do is you implement the functions for the writing commands and the data to build up the initialization sequence. I mean, you got to initialize this thing first, and then implement the OLED display initialization sequence as well as a separate, as a separate procedure that just calls all of these things, right? And task 2 is, given a character map, implement, say, a print character to the OLED display. So this is something new, right? So this is your own functionality. So you are going to, say, have this, you give it input, which is some location x, y, and at that location x, y, you will want to print, say, you have an 8-bit input called data, which is interpreted as an ASCII2 character, for example, right? So say it's the letter A, then you want to make sure that at the coordinate x, y, you're going to write a nice character A. Now, the character maps we have in the directory, so, but you would like to then manipulate the OLED display accordingly. So you would like to write those pixels that that correspond to that character that you would like to display. So that's what you need to do. You need to communicate with the OLED display and give it that information. So that's important. So now task 3 is using the function that you now have implemented. You may want to now implement an OLED print string. Why not, right? You would like to have an easy access to the OLED display. So you would like to now have a string that starts at a position and then prints your string. So that's what you do. So in effect what you see now is that you start off with the pure data sheet of the OLED display, right? Where you need to implement all its basic functionalities, just like what you're doing with the CAN controller effectively, right? But now you want to use those to implement your own way of printing strings, and those use the print character functionality, of course. Now, when you have that, then you can use the OLED display. So you can read a long sequence of text from the UART, for example, and then store it in SRAM. We'll come to that later, because now you will have to multiplex the pins of the SRAM and the OLED, and then display the text line by line on the OLED after reading from the SRAM. So that would be something that you can do yourself, just as an experiment. But once that is all set, you're done, right? So the whole idea would be later on to have an SRAM character, you say that your pixel, your big array of how to transform letters to pixel combinations in order to display those. So that's the character library. You put it in SRAM. So now in the future, when you want to say when you're building your project, right, you will actually take out. So if you want to print something like a warning message or whatever it is, well, you will be using this print string functionality that uses the print character functionality that takes from the SRAM. So now you need to read and write from SRAM the data that is needed. So that is what you will be doing in the end in order to make it all work. So let me go to. So any questions about this part so far? So all right. So let's go to this one. Oh, let me immediately, because I like to show you up. Okay, so we just talked about the OLED visible area. We talked about those pins. I've repeated that in this slide deck, but now we come to the fact that we would like to combine the SRAM and the OLED, right? So effectively what you see now is that in this data sheet, not data sheet, but this layout, we have highlighted just this portion, which is this part on in the previous slide deck, right? So it will all be connected together. So we have the SRAM that is also using all of those data lines, you see? It's doing the same thing. And that's it. You just want to make sure with your OLED enable signal and your SRAM enable signal which one you're actually communicating to. That's it. So it's very straightforward in a way, right? Okay. So what about a power supply? So let's come to that question. So well, you have a jumper on your on your board, and you can power your MCU through the USB, right? So that's what you use. There's also a second jumper that you have, and you can forward the 3.3 voltage to the MCU board itself, so that the output pins have high levels of 3.3 volts. That's what the datasheet tells you. But there's some question marks around this because you figured out it's not true. And the power, and to power the OLED, actually, the whole board, with the 3v3 pin from the MCU, can we do that actually, is the question mark. And it turns out that this particular component is missing. It turns out, if you look carefully, it's grayed out in the design documentation. So they saved a tiny bit of money, or I don't know why, but it is missing. As a result, the 5 voltage and not 3.3 voltages is forward to both the MCU board itself, giving the output pins also high levels of 5 volt. It's much more than what the OLED datasheet tells you is allowed. So it turns out though that the OLED and the other peripherals did not blow up, as we found out, because we did not know about this when we started out with this. So we're just lucky, right? Okay, we didn't know. So in this sense, you know, so let's just go ahead though. But it is good to understand though that without that second jumper though, it's very strange. The 3v3 pin does output the 3.3 volt, but we still have high levels on the output pins of 5 volts. So this is probably then the right way to approach it, because the power supply will still be the correct one if you would use this pin as a power supply for your OLED. But you know, the OLED does require the input pin highs to be at most the input voltage, which would be that 3.3 voltage. And it would be a risk to try this, but we tried it already for you by accident, and it turned out, you know, we did it, but we can actually do this configuration. We can just not use the second jumper, so that the 3.3 volts is output through that pin, right? Where was that pin? The 3v3 pin, and that can power up your OLED. And at the same time, we can just connect the breadboard to the rest of the breadboard to the 5-volt pin. So wait a minute, is that correct? Yeah, so the breadboard is connected to the 5-volt pin, and then all of this works. Now we get highs on the input pins for the OLED of 5 volts. It turned out it worked. Anyway, you could potentially use another option. You can use the 3.3 volt external regulator instead of the 3V3 pin for the power supply. You could do that as well. So anyway, you need to experiment with this a little bit. So that's what it is. You can actually indeed look at your board. I see that you're doing that now. And you can have a look. So over here, so you can have a detailed look over here in this area, where you will notice that that particular component that we see here, the where is it? The R302. You can look it up. Is actually missing. Now it may be the case that the one that you bought may have it, but I doubt it because it's not in the data sheet. So I cannot locate it right away now, but you can have a look. It's very interesting. One option could be to solder this particular component into the board itself. I think one student tried to do that, but that's kind of dangerous, right? So we're talking about someone who's just, he just loves to try these things and has experience and therefore try to do something like that. But anyway, so this is pretty interesting to notice. Who would have known, right, that such a component is missing and grayed out? So this is maybe a lesson also for the future, right? If you guys are, do you see it?
There's like a couple connections that are just missing, like right around the power supply.
Right, yeah. So what you will notice later on, right, if you buy components from other vendors and so on, wow, maybe you have to look. The datasheet may not exactly do what you thought it would do, and you may have to look really at whether everything is even enabled, right? So this is hidden. Nobody told us this, right? For all we know, we would have blown up a lot of stuff and not knowing what's going on. I don't exactly anymore know how we figured this out. It was because of something else, I believe. All right, so, oh, hey, what's going on here? Oh, that's good. All right, so, what's going on here? All right, so we have this sequence. We talked about this already. We have these tasks. So about the solution guide. So you want to set up the board with the OLED and then check the functionality using the hex files provided. So we have given you hex files. In other words, you cannot do reverse engineering and figure out what the underlying code is, but you can run the hex files, and through that you can just check whether your OLED is actually working, because it has the initialization sequence and all that, right? So you will figure out whether that works. So once you know the hardware is fine, then start coding up. So you first implement the write command data functions using SPI mode. Again, use this. Do check the wiring for the 4-bit SPI mode from the data sheet. You do this. Then use the hex code provided to test the SPI mode. So you can do, we have a hex code for that as well. Then implement the initialization sequence carefully from the data sheet, and this could be hard to debug, because how do you know whether you made a mistake? There's no such a thing. I mean, the code, the C coding on its own is syntactically correct, but how do you know that you did it right? So you need to be very diligent about looking at the data sheet. So now you pour the write command data functions and wiring over this parallel mode, and you test the same initialization sequence. This is just a suggestion, of course. The way, however you do it is fine. But this would be one step at a time approach again to getting it all to work for you. So effectively what you want to do is you want to create configuration functions for data and control, and you want to then do the write functionality. So you write the commands or data. And again, you will use a whole bunch of definitions. You assign certain types of ports, you give them standard names again, right? And in our setup, we would have certain ports associated to these, or certain pins associated to those. There is a column start, because it starts at 28, as far as I remember from the previous slides, and the column end is at 91, I believe. And then we have a row starts at 0 and goes all the way up to 63 or something like that. So that's what these indicate. And so if you're going to look at a configuration for your data port, yeah, you just want to make sure you set the directional registers again, right? You make sure that the ports, the port register is set accordingly. And similarly for a control port, I don't actually know why we did not use these kinds of names for here. That would be, in that sense, this is bad programming, right? You would like to use those names in here in order to make it properly, in order to do it properly. But anyway, as you can see, we also code up mixes of solutions together. But this is kind of the nice way to do it. So now you interpret this as the port and you set it all up properly. And this is of course much easier to read than this, right? What does this mean actually? So you have some comments here, but you still need to look at the datasheet, what's going on. Well, this is much easier to interpret. So try to do this if you do it. But then again, if your colleague gives you something like that in a future project, then why would you not use it, right? Why would you try to recode it like that? That's fine, you just go with it. So then you have the write port. It's again a very simple thing. You just, you know, clear the data port bits. You set these ports again with the data that you would like to write, and that's it. So what do you need in order to actually write to the OLED? So that was all configuration, right? Or setting the data on the lines and so forth. You would like to do this. So effectively you would first like to make sure that this goes low, then this goes low, then you use this particular thing to write. Well, you first configure it to data or control, then you use this particular guy to write the data, and then you push this high, and now the OLED receives it and interprets it. So that's effectively what we're doing.